So this is lecture 6, where we'll be looking at cost management. And in particular, we'll be looking at overheads, payback, and cash flow. So this is the second of 3 lectures where we look at cost. So just to illustrate where we are, this is now lecture 6, and there's one more lecture to go. So by now, just by way of reminder, you should have completed task 1 and task 0. You should have received your marks for that. You should have completed task 2. That's currently being marked, and you'll be receiving your marks soon. And you should now be working on task 3. You have completed the first class test, you have your marks for that, and you should now be working on these 2 tasks. So the video interview and the commercial awareness task, which is actually the digital storytelling task. Okay, you should have completed the resilience questionnaire, and this will come up right at the very end. So all that really remains in this module is your final class test and the submission of task 3. So just a reminder of what we covered in lectures 4 and 5. We introduced the idea of risk, a risk register, how to identify, quantify, prioritize, and model risk. We then introduced the idea of cost management accounting. We spoke about different types of accounting, different types of cost management. We spoke about cost centers, cost units. We spoke about classifying cost into prime costs and overheads, direct costs and indirect costs, and we spoke about the loss in value that we refer to as depreciation. We spoke about the different models that we use to calculate depreciation. Now this lecture we're going to look a little bit further at the idea of cost. We're going to look at overheads. So we introduced the idea of indirect costs and overheads, but now we're going to look at how these overheads or how these overhead costs are absorbed into the cost of the actual cost units. We're going to distinguish between production overheads and general overheads. We're going to spend some time answering a few questions about that. We'll then look at the idea of payback, net present value, and discounted cash flow. So, overhead absorption. Remember when we brought up the example of Greg's Bakery and we said that there's 2 types of cost. There's the direct cost of the materials and the labor that go into producing the pastries. So we have direct material, direct labor, and direct expenses like the expenses for operating the equipment. And we call that the prime cost. But we said there are other costs, invisible costs, which also contribute to the production cost of your pastry. These are indirect materials, things like coffee cups and napkins, and indirect labor, so the wages for the cleaner, for example, and other indirect expenses like the rent of the shop. And these contribute to something that we call the indirect cost, so of the overheads. And today we're going to be talking about how these overheads, how we pay for these overheads. Okay, so we have our production cost, which is the sum of these 2. But as we're about to see, there are other costs or other overheads which also need to somehow be paid for. So for now, what I want to say in this slide is what we've looked at so far is only the cost of production. We haven't looked at other overheads not directly related to production. So take a hypothetical example. Take some factory that produces widgets. It's got a factory that actually makes the widgets, and it has a head office that does all the sales, the marketing, the research, all the accounts, everything else which isn't involved in production. Okay, so you've got production and you've got non-production, everything else. Okay, so in this case, it's your head office, and this could be your actual factory. So the factory is what we call a production cost center, because they're actually making stuff. It's a cost center because, remember the definition from the previous lecture, it satisfies that definition. So our factory makes stuff, but also costs the business. The head office doesn't make stuff, so it's non-production, and it also costs the business. So today we're going to be looking at how is the cost of this covered by what we make here. So it's called overhead absorption. So what we're making, our unit of production, we're going to call a cost unit. Okay, so that's our produced item. It could be a delivered service, or it could be an item, it could be a combination. But this is what we're making. This is what we're selling. This is what has value. This is what is bringing in the money. This is what the factory is producing. So remember we spoke about prime cost. So the labor and material and equipment costs contribute to the production cost in this factory. But just like when we spoke about the bakery, there's also production overheads. So the production overheads are related to the production cost center. So the factory itself will have overheads. The factory itself will have security staff, secretarial staff, stationery, rent, insurance, heating, lighting, all these things. Are these things necessary to produce the widgets? Yes, of course. So these things are necessary to operate the factory, and the factory produces the widgets. But these are not prime costs because they don't relate directly to the raw material or the labor or the machine costs. All right? So together, these two costs constitute the production overheads. The other type of overhead is the non-production overhead, the general overheads. And these are the overheads that aren't directly related to the widget. They're related to operating the company. So things like sales and marketing, human resources, R&D, etc. These might not be in the same building as this. It might be in a different country. Right? You could have the head office in London, and you could have the factory in China. But somehow, the widgets produced by the factory need to cover the cost of the head office in London. So that's the idea of overhead absorption. So we're going to be talking about absorbing these overheads. First, we'll be looking at general overheads, and after that, we'll look at general overhead absorption. So, overhead absorption is dividing the overhead cost in some way into the unit cost. So the unit cost is equal to the prime cost plus some share of the overhead cost. It's not enough to say, well, the unit cost is equal to the prime cost. That's like saying the cost of a cup of coffee should equal to the cost of the ingredients of the cup of coffee plus the wages of the person who made the cup of coffee and the cost of operating the machine. We still need to include in that cost the cost of running the store. So the cleaning, the security, the rent, the insurance. So that's the production overhead. But then the company will have its general overheads as well. So when we say the total overhead cost, that's our production overhead relating to the coffee shop, and the general overheads relating to the company. Okay, so we'll be looking at this first and this next, but just remember what we're talking about is how to get these costs covered by the unit cost. Now remember, today we're not talking about price. We'll look at price in lecture 7, in our final lecture. Today we're looking at cost. What's the cost to the company of producing this cup of coffee? So let's start talking about absorption of production overhead. Okay, so remember we said we had general overhead and production overhead. First, we're going to be talking about production overheads. So, the overhead absorption rate, OAR, is a ratio. It's the fraction of the total production overhead allocated to each unit. So it's the total production overhead of that cost center divided by total number of units in some appropriate absorption base. Now that base could be the direct labor hours, wages, materials, prime cost, machine hours, cost units, or other things. And we're going to be looking at examples of each of these in a minute. But the cost of applying each of these will be different. So the total cost in the end will differ depending on which of these we choose to adopt. So consider an example. Let's say our factory, our widget factory, makes identical widgets. Okay? All of these are exactly the same. So it makes sense if we wanted to calculate the absorption base for the overheads is to divide the overhead divided by the total number of units produced, because all the units are the same. So if I made 1,000 units, I can divide the overhead by 1,000 to know how much of that overhead to include within the widget or within the widget cost. Okay, so that's absorption base number 1. Another way of doing it, if, for example, our unit our cost units, sorry, that's the word I wanted. If our cost units are not identical, let's say they're different, what I could do is I could divide by the cost of the material. So here, because they were identical, I could just divide by the number of units I make. When they're not identical, it makes sense to find something else, such as the raw material cost. All right, so this is base number 2. Another way of doing it, if some of our cost units have different designs, some have more intricate designs, so therefore they might require different amount of machine time or manual labor. I can divide not by the number of units, not by the material cost, but the amount of time it took to make it. All right, so this might take half an hour, this might take 1 hour, and this might take 3 hours. So depending on how much time was taken, or the total amount of time involved, I can then use that as an absorption base. So that's absorption base number 3. Similar, but slightly different, it could be that what's involved isn't a machine, but it's a specialist. So it could be that I'm paying more to produce one cost unit compared to another, and therefore it would make sense that I would use my labor cost rather than our machine time. Right, so here we have time, here we have material cost, here we have number. So number 1, number. Number 2, raw material cost. Number 3, machine hours. And now number 4, we have labor costs. And that you can think of other ways of doing it, but these are 4 very common ways of doing it. And let's look at an example. Let's say we have a cost center and we have some tabulated data. So the total overheads for a particular period in time are £12.9 thousand. And the question is, how can I distribute, how can I absorb that overhead into my cost unit? So you have your cost unit, whatever it is. It has some prime cost. That's the direct cost. So the prime cost is the materials, the labor, and the equipment or machinery time or cost involved in making it. But you also have the overheads. And the question is, how can I calculate this fraction for each cost unit? So let's look at the data given here. We know that in this period, we've made 535 of these widgets, 535 cost units. So if I wanted to use my first basis, which is per unit, I can simply divide that by 535. So divide my overhead figure by 535. That gives me £24 per unit. So I can say, okay, every one of these widgets will cost £24 extra per unit to cover the £12.9 thousand. So 535 multiplied by 24 will give you that. So that's my first absorption base. I could instead divide 129 or 12,900 by the number of hours, labor hours. Dividing that will give you £9.21 per hour. I could use it as a percentage of the prime cost and say, well, the prime cost is the sum of these two. So where's the prime cost? There. You've got these two. That makes your prime cost. So together, that's 3,600 plus 7,500. That's there. And if you divide the two, multiply by 100, that'll give you your percentage of prime cost. And you can do the same for the machine hours and the same for the wages. So that gives you this column here, which is the different overhead absorption rate bases. And we're going to use this in the following slide to calculate the unit cost. So remember what we're trying to do. We're trying to find what the unit cost should be. So clearly it should be the prime cost plus something. That something could be this, could be this, could be this, etc. So we've produced a cost unit. Okay, so this is what I illustrated previously there. So we've produced a cost unit. The question is, what should the cost of this unit be? We're not talking about the price, we're talking about the cost. How much has producing this cost unit, this widget, this item, this cup of coffee, this pastry, how much has it cost me? Well, obviously, we have the prime cost. Okay, so this is the prime cost. So it will cost £16.5 plus £17.5. It'll cost me £34. Okay, but that's only the prime cost. That's not the whole story. That's just the obvious bit. That's just the cost of the material and the wages. So the question is, how much do we add to that £34 to come up with the total cost? So we know what the prime cost is. The prime cost is just £34. But we need to decide on the overhead, and that will depend on what overhead absorption base we'll use. Remember we said we had the 1, 2, 3, 4. So depending on which base we choose, the overhead will differ, this bit will differ, and therefore the total cost will differ. So if we simply say per unit, this is our first method, £24 per unit, that means I'll simply add £24 11p to my 34, and that's my total cost, £58 11p. If I chose to take a percentage of the prime cost and say, well, we've already calculated that to be 116%, then I'd simply take my 116, multiply it by my prime cost. So let's do that here. So 116% multiplied by my prime cost. That will give you £39.34. And if you add the prime cost of 34, that'll give you £73.44. So you can do the same for each of these and see where these came from. So if we agreed that the OAR using labour hours is £9.21 per hour, and we know that we're using 5.5 hours, so you simply multiply 5.5 times 9.21, that'll give you £50, add that to the 34, and that's £84.65. So you can see how the total cost differs quite significantly from £58 all the way to £96, depending on what OAR base we choose to use. So that was talking about production overheads. Okay, all of that was about production overheads. Now we'll be talking about general overheads, i.e. overheads not related to a production cost center. So remember how we said that our widgets are produced by a factory, and the factory has prime costs and overheads, but the company also has a head office that doesn't produce anything. So it's non-production. It's a non-production cost center. Where here, so it's already written here, it's a non-production cost center, whereas here it's a production cost center. So we have two different types of overheads. We have the production overheads, and we've spoken about the different overhead absorption rate bases, OAR bases. Now we're going to talk about the general overheads. How are these general overheads absorbed? So remember how I said that the unit cost for my cup of coffee or my widget will consist of my prime cost plus my overheads. Now I need to split that into production overheads and general overheads. Okay, so we've got the prime cost, and we've got general overheads, and we've got production overheads. All three of these will contribute to the final price tag. So take an example. Say my factory has a head office and it's got two factories, Factory A and Factory B. Okay, so this could be a large multinational company that has a head office in California and factories in Europe and Brazil or in China and Europe. So it could be a company like Tesla with a large head office and different factories around the world. So the factories, they actually make stuff. So these are called production cost centers. Okay, so these are production cost centers, and the head office doesn't make anything. It's a non-production cost center. I call it a cost center because it costs the business money to run. So each of these is a cost center. The difference is that these factories also produce things, whereas the head office doesn't. So the head office costs the business £45,000. Factory A, say the Chinese factory, costs £75,000. Factory B in Brazil costs £50,000. So as a percentage, the 45 out of 75 plus 50 is 36%. So the head office costs the business 36% of its total operational costs. So £36 out of every £100 that the company spends is spent on this head office. Now, this £45,000, how is it going to be split? This bill, how is it going to be split between the two factories? Who pays more? You would imagine that the factory producing or costing £75,000 would pay a larger contribution to the 45k than the other factory. So if you just calculate the ratio of A to B, or the percentage that they contribute to the total, you'll see that factory A, the £75,000 is 60% of the total production cost, whereas the 50 is 40%. So that basically means that 75 over 75 plus 50 is 60%. And 50 over 75 plus 50 is 40%. Right? So that's where that came from. That's where that came from. So what does that allow me to do? It allows me to then calculate how much each production center should contribute. So I'll say, well, if the total bill is 45k and factory A costs the business, or its production is 60% of the total, then it'll pay 60% of the 45k. So 60% of 45k is 27k. That's how much factory A contributes. Similarly, factor B will contribute 40%. And the total will be the 45k. So that's how different production centers would share the cost of the general overheads. Let's take an example. Say we have a job where we're producing 30 of a particular type of widget. The question is, how much will the job cost? Now, remember, the factory has, or the company has, two factories and a head office. It's factory A that's producing these widgets. How much has it cost to produce these widgets? Well, it cost £1,500 prime cost, and then the production overheads, remember those? Remember the production overheads with the OAR bases? For whatever OAR base we used, ended up with £500. So the sum, that gives me my production cost. My production cost is the prime cost plus the OAR base. So if we go back to our example, we've got the prime cost then we've got the production OAR, or the production overhead, sorry. So this is the production overhead. And what remains is this general overhead. The question is, what share should that have? So, remember we said that factory A had 60% of the production cost. And we said that the head office, that 45K, was 36% of the total production cost. So if you multiply 36% times your total production cost, that gives you £720. If you add that to your production overheads and your prime cost, that'll give you the total job cost. So this 720 is right here, 720, and that is my general overhead. Okay, so we've got the prime cost, we've got production overheads, and we've got general overheads. Together, all three give you your total job cost. That's not the price, that's the cost. That's how much it's cost our company. It's cost this much to make it, plus this much to make the production, to make the production center function, and this additional 720 just to run the general office. So 1,500 prime cost, £500 in production overheads, and then an additional £720 in general overheads. Another example. This time, the point I'm trying to make is that when we try to absorb these costs, what we often do is make estimates. These estimates are often wrong, and that might result in an underabsorption or an overabsorption. An underabsorption means we don't manage to reclaim all the overheads because our estimate was wrong. So, for example, let's say you had an estimated overhead of £85,000. You estimate, you project, you model that your machine will be operating for 7,500 hours, and you calculate a OAR based on the ratio of those two. So you divide these two numbers, and that'll give you an OAR of £11.33 per machine hour. That's your prediction. Now, over the course of the year, many things can happen. It could be that your overheads are not what you expected they were. So you have a lower overhead, but it could, for many different reasons, it could be that you don't operate the machine for as many hours. So when you divide the two, you won't get the same number. So if you were to use your £11.33, but then use the existing machine hours, you would end up with a shortfall. You would end up with less than the actual overhead. So this £952 is £952 that haven't been covered by your cost calculations. So that's called underabsorption. And underabsorption isn't good. It means that our model hasn't been able to recover our overheads. Now, the opposite is overabsorption. In overabsorption, that would be a negative number. It would mean that you've recovered your overheads and you've exceeded those. And again, that isn't necessarily a good situation. Remember, we're not talking about price, we're talking about cost, and it's important for a business to be able to identify its costs accurately so that its pricing can be based on those costs. So if you don't model correctly, if your estimates and your actual figures are so far out that you end up significantly over absorbing your overheads, it means your calculation of cost will be too high, and therefore that'll affect your later pricing. Let's look at an example. So let's say in a particular month you have total overheads of £10,000. All right, so that's what we're trying to recover. And we have different bases of doing that. We can recover it based on the number of items we produce, based on the hours, based on wages, based on materials, or based on time. So notice all these different things: units, time, cost, wages, time. So simply dividing that by each of these will give you a different OAR. And the question here is, which of these is incorrect? Okay, I'll leave you to do the calculations. But there you go. The 422 doesn't work. And here we have another example of identify the incorrect OAR. No, sorry, this was the answer we were just, this is the question we were just looking at, and this is another one, which is the correct cost. So I'll leave you to look at this example, and we'll move on to look at cost analysis. So in the final part of this lecture, we're going to be looking at how decisions are made. Okay, so we've spoken before about how decisions are made about project selection and project scheduling. Now we're going to be looking at project costing. So often we end up making decisions about project costing and project selection based on short-term operational planning. So we're going to be looking at something called the break-even point. Next lecture we'll be looking at special order contracts. We'll be talking about profitability. So we need to understand costs and cost behavior, because that influences how managers make decisions. So the first thing we want to look at is something called payback period. So payback, typically in years, is the time it takes for cash inflows to equal cash outflows. i.e., how long will it take for a project to begin generating more money than it spends? All right, so cumulative cash flow would be 0 during payback year. So you start a project, you invest a large sum of money in it, you want to know how long will it take for me, for this business or for this project to no longer cost me money, i.e., I want to be able to reclaim my money back. I want the cumulative cash flow to be 0. I want to be generating more money than I have spent. And the basis we use for accepting a project is often, not always, but often, the shortest payback period. So if you have two projects that are otherwise identical, one with a shorter payback period than the other, that's often the one that we would select. Okay, so this is the decision rule that we'll be adopting. So for example, let's say you've got three different projects, A, B, and C. So project A cost me £120,000 to set up initially in year 0. So this is a cash outflow. This is how much it cost me to set up. Now, the first year the company generated £60,000, or the project A generated £60,000. In year 2, it generated £60,000. In year 3, it generated £60,000. The question is, what's the payback? Well, the payback period is 2 years. That's 1, that's 2. So it took 2 years to recover the £120,000. Now, project B also started off costing me £120,000 initial investment, but it only bought me £50,000 in the first year, 50 in the second, and 50 in the third. So how long would it take to recover the £120,000? Well, 1 year, 2 years, and then part of the third year. So the first 2 years will give me £100,000. I'm still short of £20,000. So 120 minus 100, that's my £20,000. What fraction of 50? Because that year will bring in £50,000. That's the fraction of the year, which is 0.4 of a year. So that's 0.4. So my payback period will be 2.4 years. So simply comparing project A and project B, I would accept project A and reject project B simply based on the payback period, that this pays me back sooner than the second project. Project C is different. Project C it pays me back £40,000 in the first year, but then £100,000 in the second year, and even more in the third year. So it's not a constant inflow of cash. So the question now is, how long would it take to get back my £120,000? So it looks like it would be less than 2 years. So £40,000 in the second year, so 120 minus 40, that's 80. Divide that by your 100, and that's 0.8. So in total, it would be 1.8 years. So it looks like project C would win because it's less than 2 and less than 2.4. So project C, in this case, would win. So all three projects are identical in the sense that they all cost exactly the same outflow in year 0 to start, but the payback period was smallest for project C. Now, finally, the last thing we want to spend some time looking at is something called discounted cash flow. And this is about the value of money. Now, it's important that we understand flows of money into and out of a project. So just now we were talking about this £120,000 in year zero and then different sums of money in different years. It turns out that the value of money isn't constant. We think of money as losing its value with time. We think of money as having a decreasing value with time. But I need you to think of that in reverse. Think of money as increasing its value in time, even though that's slightly counterintuitive. So think, even though that the purchasing power of currency seems to decrease with time. So £1 in 1968, today in 2020 is worth anything between 14 and 26 pounds. So it seems that the actual purchasing power of that single pound has decreased. But if you had a project that spanned a large duration, number of years, then it would make sense to understand the value of money at different points in time rather than simply using the sums of money. So, for example, if we have an interest rate of 5%, then £100 today is equivalent to £105 in a year's time. So it seems like the value of money has increased. It hasn't actually increased. In a way, it's the opposite that's happened, but we need to understand that £100 today is equivalent to £105 in the future. And that means that cash flow at different times in the project isn't directly comparable unless we use some kind of common basis. So we need to understand how the value of money changes with time. So just think about this for a second. At a 5% interest rate, £100 today is equivalent to £105 next year. That means if someone promises to give you £105 next year, that's just £100 today. So the £100 today is what we call the present value. And the £105 is a future value. So if a project is funded in such a way that you have a future funding stream where you have £105 coming in a year's time, you need to be able to recognize that that's only £100 today. And we'll look at that in a little bit more detail in a minute. So what we're going to use as a common basis is now, the present time, the present value. So present means now. Okay, so we're going to use that as our common date. There are other ways of doing it, but a common, fairly simple way to do it, and the way we're going to be using it in this module, is to compare all sums of money to their value today. So what we do is we calculate something called the net positive value. So we add up all the different cash flows and we calculate something called the net positive value. And I'll show you how to do that. But we then look at whether that value is positive or negative. If it's positive, we accept the project. If it's negative, it's a loss, and we reject the project. So take a simple example of £1. Okay? And we have some interest rate R. The value today is, we're going to use P for present. and the number of years, n. Okay, so we've got P, N, and R. So let's say we spend or invest £1 today. How much will that £1 be worth a year from now? No, that's not what this example actually says. It says, consider £1 a year from now. So someone is promising to give us £1 a year from now. How much would that cost today? So what's the present value of this £1? So remember, a couple of slides ago, we said £105 in 1 year at 5% is equivalent to £100 today. So that is what we would call P. The 5% is what we would have called R. And the 105 is, in this case, what we're using 1 for. Okay, so if you do the same for 2 years, you have that happening twice. And if you rearrange, solve for P, you come up with that. That's for £1. So if it was for any other value, you'd simply multiply by that value, in this case 105. So this is my updated formula where instead of the 1, I've got F, which is my future value or future sum. And look at this example. Say someone is promising us not £105, but £25,000, but he's offering it to us in 4 years. So 2024, that means we're in 2020 now, so that's 4 years. The 7%, that means R equals 7 over 100. We're expecting 25k, so that is my future value. So the question is, what is the net present value? So that's P. I don't think we even need the word net in this case. What's the present value? What's P? So we simply plug the numbers into the formula. So it's F divided by 1 over R to the power n, or 1 plus R to the power n. And in this case, it'll give you just over £19,000. Another example is, or another scenario, is where you have more than 1 year. So you have £25,000 in 1 year, then you have another sum the next year, etc. So if you have a number of years, then you would have a number of cash flows and you would add all those up together. So that's where the N comes in, the net present value. So what we had here was the present value. Now we have the net present value. The net present value where we're adding these together. So it's simply F over 1 plus R to the power N, but instead of N we're using I, and instead of F we've called it CI, but it's the same. Okay, and this factor here, 1 over 1 plus r to the power I we call the discount factor. So as an example, remember we had our project A, B, and C, and every year there was expenditure or cash inflow and outflow. Same idea here. We have a project and we have 6 years. Year 0, there's an initial investment of £2,000, and then each year after that we have some income. And the question is, what's the net present value? Net present value, so we're asking about how much all of this is worth today. How much is it worth today? That's what we're trying to find. So this £400 isn't actually £400. It's actually £400 divided by 1 plus (0.1) to the power 1. And that £600 is actually 600 divided by 1 plus 0.1 to the power 2, etc. So each of these is actually worth less. So this £500 in 5 years' time is actually not £500 at all. It's 500 times 0.6. So it's less than £350. So if you add all these together, you end up with a positive number. And remember what we said in terms of the decision basis. We said if the net positive value is positive, the project is acceptable. If it's negative, it's not acceptable. So in this case, with r equals 10%, this project over 5 years with this level of income and at this interest rate is still acceptable. But if the interest rate were 20%, then each of these will change. That will become 0.2. That will become 0.2. So you wouldn't end up with 105. You'd end up with less. And if that was negative, the project wouldn't be accepted. So here at 20%, it turns out you end up with a loss. Even though if you add up these numbers, that's more than 2,000, isn't it? Okay, that's 2.7 or 2.6 thousand pounds. So even though when you add these up, it's more than your initial investment, it still looks like the project is unacceptable. Okay, so it depends on the interest rate. So a question like this might even say, what interest rate, or at what interest rate would this project be acceptable? Or what is the highest interest rate, or it's called a discount rate. So what's the highest interest rate or discount rate that this project would remain acceptable? Finally, last couple of slides, this is an example for you to try at home. Again, we've got two projects, X and Y, and you need to calculate the NPV with a given discount rate. And another example for you, slightly harder. Again, you're given certain information. have a go at that. I've got the answers there. If it isn't clear, ask and we can go through it together. Okay, so finally, just a reminder that task 3 is a substantial amount of work required. You have a little bit more time before the deadline. But finally, let me summarize today's lecture. We spent some time talking about overheads, and we talked about production overheads, and we spoke about general overheads, and we spoke about the different ways in which overheads can be absorbed. Then we spoke about payback and payback period. We spoke about net present value and discounted cash flow. And in our final lecture, we will talk further about different costing models. So where are we now? We have finished lecture 6. That was lecture 6. What remains now, our final lecture, is lecture 7, coming up next week. And lectures 6 and 7 will contribute to task 3. And your final class test will cover all 7 lectures. So all the content from lectures 1 to 7 will contribute to your final class test.